In organic chemistry, a phenyl group or phenyl ring is a cyclic group of atoms with the formula C6H5. Phenyl groups are closely related to benzene. Phenyl groups of 6 carbon atoms bonded together in a hexagonal planar ring, 5 of which are bonded to individual hydrogen atoms, with the remaining carbon bonded to a substituent. Phenyl groups are commonplace in organic chemistry. Although often depicted with alternating double and single bonds, phenyl groups are chemically aromatic and show nearly equal bond lengths between carbon atoms in the ring. Nomenclature: usually, a phenyl group is synonymous to C6H5 euro, and is represented by the symbol PH or, archaically, I. Benzene is sometimes denoted as PHH. Phenyl groups are generally attached to other atoms or groups. For example, triphenylmethane has 3 phenyl groups attached to the same carbon center. Many or even most phenyl compounds are not described with the term phenyl. For example, the chloro derivative C6H5Cl is normally called chlorobenzene, although it could be called phenyl chloride. In special cases, isolated phenyl groups are detected, a phenyl anion, a phenyl cation, and the phenyl radical. Although pH and phenyl uniquely denote C6H5, substituted derivatives also are described using the phenyl terminology. For example, O2 North Carolina, 6H4, is nitrophenyl and F5C6 is pentafluorophenyl. Etymology phenyl is derived from the French word fair copyright Nile, which in turn derived from Greek phaino shining, as the first phenyl compounds were byproducts of lighting gases. Structure, bonding, characterization: phenyl compounds are derived from benzene, at least conceptually and often in terms of their production. In terms of its electronic properties, a phenyl group is related to a vinyl group. A phenyl group is hydrophobic. Phenyl groups tend to resist oxidation and reduction. Phenyl groups have enhanced stability in comparison to equivalent bonding in aliphatic groups. This increased stability is due to the unique properties of aromatic molecular orbitals. The bond lengths between carbon atoms in a phenyl group are approximately 1.4 A. In 1-hour NMR spectroscopy, protons of a phenyl group typically have chemical shifts around 7.27 ppm. These chemical shifts are influenced by aromatic ring current and may change depending on substituents. Preparation, occurrence, and applications: phenyl groups are usually introduced using reagents that behave as sources of the phenyl anion or the phenyl cation. Representative reagents include phenylithium and phenylmagnesium bromide. Electrophiles attack benzene to give phenyl derivatives, C6H6 plus E plus a C6H5 E plus H plus, where E plus equals Cl plus, NO2 plus, SO3. These reactions are called electrophilic aromatic substitutions. Representative compounds containing phenyl groups. Phenyl groups are found in many organic compounds, both natural and synthetic. Most common among natural products is the amino acid phenylalanine, which contains a phenyl group. A major product of the petrochemical industry is BTX, consisting of benzene, toluene, and xylene, all of which are building blocks for phenyl compounds. The polymer polystyrene is derived from a phenyl-containing monomer and owes its properties to the rigidity and hydrophobicity of the phenyl groups. Many drugs as well as many pollutants contain phenyl rings. By one of the simplest phenyl-containing compounds is phenol, C6H5OH. It is often said the resonance stability of phenol makes it a stronger acid than that of aliphatic alcohols such as ethanol. However, a significant contribution is the greater electronegativity of the sp2-alpha carbon in phenol compared to the sp3-alpha carbon in aliphatic alcohols. References